In this video, we're counting selections, combinations, higher level only. And we're finishing the question we opened with last time. 8 runners, 336 ways to award the medals. That one we did. 56 ways to pick 3 of them for a drug test. That one is this video. And 336 divided by 56 is exactly 6. Not roughly 6, exactly. That 6 is not a coincidence. And once you see where it comes from, you will never mix these two up again. So let's find it. Take one selection. Anna, Ben, and Cara. When we counted podiums, that same set of 3 people got counted 6 separate times. Once for each order they could stand in. Anna, Ben, Cara. Anna, Cara, Ben. Ben, Anna, Cara. Ben, Cara, Anna. Cara, Anna, Ben. Cara, Ben, Anna. 6 of them. And 6 is 3 factorial. Every single selection was overcounted by exactly 3 factorial. So to count selections instead of arrangements, take the permutations and divide by r factorial. That gives you NCR. NPR over r factorial, which written out in full is n factorial over r factorial times n minus r factorial. You will also see it written as a tall bracket with n above r and no line between them. That is read as n choose r. Same thing. And the useful way to hold it in your head is the first one. Combinations or permutations divided by r factorial because order stopped mattering. One shortcut worth having before the examples. NCR equals NC n minus r. 8 choose 3 is the same as 8 choose 5, both 56. And there is a reason, not just a pattern. Every time you choose 3 people to take, you are also choosing 5 people to leave behind. Those are the same act. So if the bottom number is more than half the top, flip it, and the arithmetic gets easier. Example 1. Closing the question. Choose 3 runners from 8 for a drug test. Order does not matter, so it is 8C3. 8 factorial over 3 factorial times 5 factorial. In practice, 8 times 7 times 6 on the top over 3 times 2 times 1 on the bottom. 336 over 6, 56. And there's the answer we left on the board last video. Now the calculator. Every calculator you are allowed has an NCR button. 8 NCR 3 gives you 56 directly. Same advice as last video. Use the button. Example 2, and this one is just the decision, drilled. 3 questions, back to back, and the only work is picking the right tool. 1. Pick 3 people from 8 for a committee. The 3 of them are just members. Order is irrelevant. 8C3, 56. 2. Pick 3 from 8 to be chair, secretary, and treasurer. Now the 3 roles are different. Being chair is not the same as being treasurer. Order matters. 8P3, 336. 3. You've already chosen which 3 people. Now assign the 3 roles among them. That is just 3 factorial. 6. And that third one is the bridge. Choosing the people and then assigning the roles is 56 times 6, which is 336. That is the entire relationship in one line. Example 3. A restriction. A committee of 3 from 8 people, but Anna must be on it. So Anna is fixed. She uses up one of the 3 places, and she is not a choice. That leaves 7 people and 2 places. 7C2. 21. And the move worth naming is this. Deal with the forced choice first, then count what is genuinely still free. Example 4. 2 groups at once. A team of 3 men from 5 and 2 women from 4. These are independent choices, so you multiply. 5c3 is 10. 4c2 is 6. 10 times 6 is 60. And here's the rule to name, because almost every multi-stage counting question is this sentence. And means multiply, or means add. Example 5. The payoff. Combinations inside a probability. You deal a 5-card hand from a standard deck. What is the probability of getting exactly 2 aces? Start with the total. The number of 5-card hands is 52C5, which is 2,598,960. Now the favorable ones. Choose 2 aces from the 4. 4C2, which is 6. Then choose the other 3 cards. And here's the bit that matters. You choose them from the 48 cards that are not aces. 48C3, which is 17,296. Multiply. 6 times 17,296 is 103,776. Divide. 0.0399, about 4%. Now, why 48 and not 50? If you carelessly took the last 3 cards from all 50 remaining, you would let a third ace in, and you would be counting hands with 3 aces as well. That is, at least 2 aces, not exactly 2. The 48 is what makes the word exactly true. Order matters. Permutation. Order doesn't. Combination. And a combination is just the permutation divided by r factorial. Next video takes NCR somewhere you might not expect. It is the engine of the binomial theorem, and we are going to run that theorem with powers it was never supposed to handle: negative ones and fractions.